Hello everybody, today we're going to talk about a third method to solve quadratics, and that method is what we call the quadratic formula. So we've talked about using square roots to solve, which we can use when there's no b. We've talked about using factoring to solve, which we will see eventually here that you can only use factoring to solve when you can factor, and there are situations where you can't factor, the x and x isn't going to work for you. But we can still solve using this third method that we're going to talk about, which is the quadratic formula. The nice thing about the quadratic formula is you can use it to solve any quadratic, right? Like I said, square roots you can only use if there's no b. Factoring you can only use if you can actually factor. Quadratic formula you can use every time. So there's been times when I've given this test on solving or this quiz and students say, well, I let you pick which method you want to use to solve. There's some times where one method works better than the other, but some students just use a quadratic formula to solve every quadratic, and that is just fine. The problem with doing that is the quadratic formula is fairly long. So this right here is how you derive the quadratic formula, and I used to make students actually do this process, but lucky for you, what I want you to do is just memorize this formula right here. It says x equals negative b plus or minus the square root of b squared minus 4ac, everything all over 2a. Again, please write this down somewhere on a little sticky note, because this is what we're going to use, and this is something that you are going to have memorized. I will show you or tell you about some resources you can use to help you memorize this at the end of today's lesson. But again, this is a quadratic formula. This is what we're going to use to find our solutions. So to illustrate how it works, we're going to jump right into an example. So it says, let's use a quadratic formula, it should say, to solve the following. So before we start using the quadratic formula, we first have to set our quadratic equal to 0, just like we did when we were factoring. So I got to move this 2x to the other side. Now I'm going to write it in standard form. So I'm going to have x squared minus 2x minus 8 set equal to 0. So once I have it like this, now we can use the quadratic formula. So again, to write it out, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, this right here, that's the quadratic formula. That's something you should memorize. So now I just got to plug values in. The a, b, and c are the same as before. Here's a, here's b, here's c. If it's helpful, you can go ahead and list them off to the side. A is 1, looks like b here is negative 2, and c is a negative 8. So we just plug things in. So what I generally do is wherever I see a variable, besides x, because that's what I'm solving for, I'm going to put parentheses. So I got negative b plus or minus the square root of b squared, so I'm going to put parentheses squared, minus 4 times a times c all over 2 times a. From here, I just go ahead and plug in my information. So it says negative, and it says plug in b. So b here is a negative 2. Plus or minus, it says b squared, so I got to plug in b again, negative 2 squared, minus 4 times a times c. So a is 1, c is a negative 8, all over 2 times a. Well, a here is 1. So before I just go crazy and plug this into my calculator, I would do some simplifying first. So what I would do is I can just do a little simplifying along the way. The negative 2, well, that's a positive 2, plus or minus. My square root kind of acts as like the parentheses in PEMDAS. I want to simplify what's under my radical first. So negative 2 squared, I got to do exponents first, and there's a positive 4 minus 4 times 1 times negative 8 all over 2 times 1, or just 2. So again, I got to keep going here, right? I got to keep simplifying what's under my radical. So if I do that in the next step, I get x equals 2 plus or minus the square root of 4. Then I got to multiply these terms together. So it's a negative 4 times 1, which is a negative 4, times a negative 8, so that's a positive 32, all over 2. All right, so I gotta keep going. I still have simplifying to do under my radical. So it looks like here I get x is equal to 2 plus or minus the square root of 4 plus 32, well that's 36, all divided by 2. All right, we cannot divide by 2 until we have our numerator simplified. So we gotta keep going here. So from here, I'd have x is equal to 2 plus or minus, well the square root of 36 is 6, so I can simplify that over 2. So here's kind of where maybe the little bit tricky part comes, or kind of the weird looking part comes. We got to find our 2 solutions. So you got to first think about, well, you got to pick one of our operations. So I'm going to just pick adding first. So I'm going to think about this. If I take just 2 plus 6, and then I divide that answer by 2. So here I'd get 2 plus 6 is 8, divided by 2, which would give me 4. So there's one of my solutions, x equals 4. Now I gotta go back and I gotta think, well, what if I subtract now? So I'd have x is equal to, instead of 2 plus 6, I have 2 minus 6 divided by 2. Again, I gotta simplify the numerator first. So I get negative 4 over 2, which is a negative 2. So my solutions are x equals 4 and negative 2. Those are my 2 solutions, 4 and negative 2. And as always, just like we do with factoring, if you want to, you can plug those back into your quadratic and it should give you a true statement. So this is the quadratic formula. Again, it's a little bit longer, but the nice thing is it works with every single quadratic. And there are some quadratics that you can't factor, so you have to use the quadratic formula. Big thing is, write out the formula, put parentheses and plug things in correctly, simplify what's under the radical next. Once that's completely simplified, then you can just take it piece by piece and evaluate. So I know that's probably a lot and it feels kind of overwhelming, so we're going to do some more examples to get some practice. So let's go ahead and scroll down. Let's go ahead and do the one on the left here. So it says use the quadratic equation to solve. So again, we got to make sure it's set equal to 0 first, which in this case it is, so we are good. So I'm going to go ahead and label A, B, and C. So from here, again, I think it's helpful just to write out the formula to start, plus it helps you memorize. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So now I'm going to rewrite it, and I'm going to put parentheses wherever I have variables. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. From here, I get to go ahead and just plug in my values. So I'm going to plug in, looks like, oops, got this little goofed up here. I'm going to plug in a, b, and c, so it says negative b, so b here is 16, plus or minus b squared, so 16 squared, minus 4 times a is 5, times c, which is a negative 84, all over 2 times a. Alright, so I can do a little simplifying along the way, but really the big idea is I want to simplify what's under my radical first. So if I do that, I have x equals, well, negative times 16 is just a negative 16, plus or minus the square root, well, 16 squared. If you need to use your calculator for that, that's just fine. It looks like it's 256 minus 4 times 5 times a negative 84. Again, this is all divided by 2 times a, or 10. Still have to simplify what's in my radical before I can do anything else. So I get x equals a negative 16 plus or minus the square root of, well, I get 256. And I got to take negative 4 times 5, which would give me a negative 20. Then I got to take negative 20 times a negative 84. So I need my calculator for that. Looks like I get a negative, or sorry, positive, because it's a negative times a negative, a positive 1,680. Again, all over 10. So I'm getting close here, but again, I still have to finish simplifying everything that's under my radical first. So I got to finish that addition. So I got to add the 256 to that 1,680. And if I just rewrite this, it looks like I get x equals a negative 16 plus or minus the square root of 1,936 all over 10. Sweet. So after that, I'm going to go ahead and simplify even further. I'm going to take the square root of 1,936. And when I do that, I get x equals a negative 16 plus or minus. The nice thing is, square root of 1,936 ends up actually being 44. It's a perfect square. So again, you need a calculator for that, which is just fine, divided by 10. So from here, I am almost done. I just got to find my two solutions. So the first one's going to come from adding. So I'm going to start by adding. If you want to write out these two steps, that's just fine. So I get x equals negative 16 plus 44 all over 10. Well, negative 16 plus 44, if we do that, looks like we get 28. So I get x equals 28 over 10, which is 2.8. Sweet. So there's one of our solutions. Now I got to do the same thing, but now I actually have to subtract. So I got to take negative 16 minus 44. So x equals a negative 16 minus 44, again still divided by 10. I have to do the numerator first, the subtraction on the numerator. So when I do that, it looks like I'll get negative 60 over 10. So my answer is going to be a negative 6. So my two solutions are x equals 2.8 and x equals a negative 6. Again, those would be my two x-intercepts if I was graphing. Again, that's how you do the quadratic formula. If we move on here, I just want to maybe show you this one here. It's a word problem. This kind of shows you how we would use this stuff. So if we just read this word problem real quick, it says the batter strikes a baseball. The equation y equals this right here models its path. It says x is the horizontal distance and feet the ball travels, and y is the height. It says how far from the batter will the ball land? Round your answer to the nearest tenth. So x is the horizontal distance, so we want to figure out what x is, right? And it says when the ball is going to land. So if we think about it, when the ball lands, what is the height going to be of the ball? Well, the height, when it lands, the height should be 0 when it hits the ground. So that means if we want to find x, we know that y is going to be 0 because y represents the height. So here's my quadratic that I have to solve for x. Again, if we think about solving this one, clearly not square roots because there's a b value. There's no way we could factor that with those nasty decimals in there. So that means we got to use the quadratic formula. So let's go ahead and do that. Again, I'm always going to start by writing the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So again, I'm going to rewrite it with parentheses and for my variables, negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So from here, I go ahead and fill in my values from my equation a, b, and c. So it says negative b, so b is a 0.7, plus or minus square root of b squared, so 0.7 squared minus 4 times a. Didn't give myself very much room here, so I'm going to plug in negative 0.005, just cram that in, times c, which is 3.5, all over 2 times a, which again is negative 0.005. Obviously, you're probably going to need a calculator to help us in the simplification process. So let's go ahead and simplify what's under my radical first. It's still the same process even though the numbers look nasty. So I got negative 0.7 plus or minus the square root of Well, let's take that 0.7 squared first. So if I take 0.7 times 0.7 or 0.7 squared, looks like I get a 0.49. And I'm actually going to do the multiplication in this step too instead of rewriting it twice. So I'm going to take -4 times negative 0.005 times 3.5. Looks like I get 0.07. And it's positive, right? Because it's a negative times a negative, which is a positive, times a positive, which is still going to be a positive, all over a negative 0.01 if I take 2 times negative 0.005. So from here, I'm just going to go ahead and add what's inside under my radical. So I get negative 0.7 plus or minus the square root of 0.49 plus 0.07 is 0.56 divided by negative 0.01. So I'm going to simplify. I'm going to take the square root of 0.56, which you're going to end up getting, I believe, a 0.75. Let me just double check this real quick to make sure I did it correctly. 0.56, take the square root. Yeah, it's going to give you a real nasty number, 0.748. Let's just make this a rule. Let's always round to 2 decimal places, so we're all on the same page. So it's 0.748, so that's going to round to 0.75 all over a negative 0.01. So from here, I just have to go ahead and find my 2 solutions. So I'm first going to add. So I get x equals a negative 0.7 plus 0.75 divided by negative 0.01. So again, we add the numerator first. So it looks like I get x equals, if I add here, 0.75 minus 0.7, looks like I get a 0.05 divided by a negative 0.01. Looks like I would get a negative 5. So there's my first answer. Now I got to find my second one. So now I'm going to go ahead and actually subtract. So I get x equals a negative 0.7. Now I'm minusing 0.75 divided by a negative 0.01. Again, simplify the numerator first. So I get x equals looks like 1.45 negative, I should say, divided by a negative 0.01. Looks like a negative divided by a negative is going to be positive, so I'm going to get 145. So this is a word problem, so we got to make sure we have labels. It says how far from the batter will it land? So we're trying to find x, and it says x is a horizontal distance in feet. So I should label these with feet. One thing with word problems, if we're thinking about how far we hit this baseball, and we're thinking about a distance, we should think, gosh, I shouldn't have a negative distance. So negative 5, we got to cross that off. That can't be one of our answers. That's not one of our solutions. We can't hit a baseball in negative 5 feet. So that means that this person hit the baseball 145 feet. Right? Negative 5 was not a valid answer. 145 is our answer. So again, quadratic formula you can use even when we have messy numbers, or that's the best method to use and probably the only method we can use if we have decimals in our answer. Process is the same. Just remember, when we have to round, please round to 2 decimal places. All right, just a few other things, or some vocab. One word that you're going to hear probably quite a bit is this word, the discriminant. And this is just the expression under the radical sign in the quadratic formula. So just this b squared minus 4ac part. That right there is a discriminant. Not the square root, just what's underneath. The discriminant can obviously be positive, negative, or it could be 0. And we use the discriminant to determine how many solutions we have. Let's see how that works. So they say if the discriminant is positive, actually maybe we'll look up here. If the discriminant is positive, that means that we are going to have 2 solutions. right? And that's what we saw on all of these up here, right? Here the discriminant is 0.56, it's positive. We ended up having two solutions. One of them we crossed out, but that's okay. Same thing up here, our discriminant was a positive 1,936, and we ended up having two solutions for x, 2.8 and negative 6. The reason that works is because if I take the square root of a positive number, remember back to when we solved quadratics using square roots, we had a positive and negative, whatever that square root is. That's why we have two solutions. If our discriminant ends up being 0, that means we would just have one solution. Because if you think about it, if we take the square root of 0, the answer is just 0. So if we take plus or minus 0, that's not going to give us two different answers because adding or subtracting 0 isn't going to change things. So that means we would just have one solution. Finally, if our discriminant is negative, that means we're going to have no solutions, no real solutions. Because, again, if we look up here, if I change this to, if we took the square root of like a negative 3 or something like that, we know we can't take the square root of a negative number. So if our discriminant is negative, then if we took the square root of it, we wouldn't get an answer. So we'd have no real solutions. So sometimes I'm going to ask you how many solutions does a quadratic have, and we can determine that just by looking at the discriminant. You wouldn't have to go through the whole quadratic formula to figure out how many solutions we have. We just look at the discriminant. Again, if our discriminant is positive, that means there's two real solutions. If it is 0, that means we just have one solution, meaning just one x-intercept. If the solution, the discriminant is less than 0, or if it's negative, that means we have no real solutions, meaning it does not cross that x-axis. So here's what a problem would look like. It says, how many real number solutions does this quadratic have? So again, I'm going to set it equal to 0 first. So I'd have 2x squared minus 3x. I'm going to add 5 to the other side. Plus 5 is equal to 0. So once I have this set equal to 0, it says how many solutions? Well, to determine the number of solutions, I just have to look at my discriminant. So just at that b squared minus 4ac. I don't have to use all of the quadratic formula. So now I just plug things in for the discriminant. So b squared minus 4 times a times c. I got a, b, and c if I want to label those over here. So b, it looks like, is a negative 3. A is a positive 2. And c is a positive 5. So if I simplify here, I got to do exponents first. So negative 3 squared is 9. Negative 3 times negative 3 is a positive 9. Minus 4 times 2 times 5. So if I keep going here, I keep simplifying, I gotta do my multiplication next. So I have 9. Negative 4 times 2 is a negative 8 times a positive 5 is a negative 40. So if I simplify here, 9 minus 40 is a negative 31. This is my discriminant. This does not tell me what my solutions are. It just tells me how many I have. And since my discriminant is negative, that means I have no real solutions. No real solutions. Since my discriminant is negative, meaning my graph would look something probably like this one up here, where it does not, or it would look something like that, where it does not cross the x-axis. One more of these just using the discriminant, and I think we'll probably call that good for today. Let's maybe just look at 33. So use the discriminant to determine how many real number solutions exist. So again, I just got to find b squared minus 4ac. That's the only part. I don't care what the solutions are, I just want to know how many I have. So if I'm labeling what a, b, and c are, a is clearly 1, b is 2. It looks like there's no c value, so really c is just going to be 0. So b squared, so I plug in 2 for b, a is 1, c is 0. So if I simplify here, I get 4 minus 4 times 1 times 0. Keep going, I simplify, I get 4 minus 4 times 1 is 4 times 0 is 0, so I get 4 minus 0, so my discriminant is 4. So since my discriminant is 4, and more specifically since it's a positive number, that means I would have 2 solutions. Again, I don't care right now what those solutions are, I just care that there are 2 of them since my discriminant is positive. So again, to recap, if my discriminant is positive, I have 2 solutions. If it is 0, I have 1 solution. If it is negative, then I have no solutions. So this is our lesson on the quadratic formula, and we talked about that discriminant within the quadratic formula. Your homework for today is just to look up, I'll post a couple YouTube videos that are really helpful. They're kind of clever videos that people use to help memorize the quadratic formula. I ask that you look at those and maybe look up some other ones, but really your homework is, after watching this video, just try to memorize the quadratic formula. In the next lesson, I'll do a few more kind of review questions, and then I will have some, I believe, delta math for you to do to practice the quadratic formula. Again, your homework for now is just to memorize the quadratic formula. As always, if you have questions, email me at storeandflip@gmail.com. Thanks and have a great day.